Okay, I'm going to shut down some of this other stuff to maybe speed it up a little bit. Okay, hopefully that helps. So we are now recording. So what gets recorded is everything that's up on the screen, basically my computer screen, and what gets projected up on the front of the room there, with any sound laid over it. So my voice laid over it. I'll give you a little example of what that'll look like. I'll go to one of my other classes. This one should have a couple out there.
Marquito's arriving, Richmond.
Okay, thank you. We actually have everybody. This will be the first class of the semester that I've had everybody show up for on the first day. Cool. So, like, this is one of my other classes. You can see here I've got all the same, similar stuff, my information, syllabus, schedule, and at the bottom of that course information page, there's the links. These often don't work well if you just click on them. So a lot of times you either have to copy and paste them or open in a new tab, and it seems to work better. And there is the YouTube video. So you can see what's being seen here. That's what goes up on the computer screen. I have the volume shut off right now, but it'd be my voice laid over the top of it. So feel free to use those however you want to. I know with the medical fields, you have clinicals and stuff like that for some of you. So the schedules get kind of tight. So if you have to miss a class, that's a great way to make it up. I'm not putting them out there as an excuse for you not to come to class, but I do understand you have busy lives. So you have them there to help make up. I have a lot of students. I realize I tend to talk kind of fast. A lot of students can't keep up with notes, so they use these to go back and fill in their notes later. If they got a little bit behind, they'll just leave a blank spot in their page and go back and fill in later. I've had some students who just sit in class and listen instead of taking notes and go back later and take notes off the videos, which works great for them. They do very well in the class, but that turns a 2-hour lecture into a 4 or 5 hour lecture really fast if you got to go home and watch it again. I'm not saying you should do that unless you got a lot of free time. But use them however you want to. If you want to put them up on the big screen and invite some friends over for the weekend and pop some popcorn, go ahead. If you charge admission, I get half, by the way. For those of you who don't know me at all, I'm kind of kidding. Okay. We'll go through the syllabus quick. There's my contact information, a little bit easier to see. Best way to get a hold of me is email. I check my email at least once or twice a day here, so I'll get your message pretty quickly. If you can't get to email and you have to contact me, there is my voicemail extension. I have Rice Lake campus number there, but you can call any campus or the 800 number and then dial that extension. It'll get you to my voicemail. Or if you're in the school, you just pick up any of the school phones and dial that extension and it'll go to my voicemail. Just for full disclosure, I'll probably never answer the call in my office because I'm never in my office, but leave me a voicemail and I'll get back to you. I have it set up so it forwards a message to my email when somebody leaves a message, so I'll know it's there. Everybody's here, so I don't need to go over where and when class meets. And actually, these rooms are probably different now, especially Ashland and Superior. I understand with the construction, you guys got jostled around. Course description and course competencies. There are 5 units in this course. Our first unit is basic arithmetic and basic algebra. So we'll go over operations with numbers, percents, order of operations. Then maybe some light equations. Second unit is measurement and measurement conversions. That's very important background information for your dosage calculations, which is the third unit. The dosage calculations is the meat and potatoes of the class for most of you. It's what you have to be able to do out in the field, and that's what we'll spend the most time on, probably about 4 or 5 weeks on that, depending on how the schedule works out. The fourth unit is one we had to put in there to make this justified as an associate degree course, because all of our associate degree classes have to be college transfer. So the fourth unit is our little bit of graphing and basic geometry, algebraic geometry. So that's in there. And then the fifth and final unit usually gets cut a little short. That's statistics. That's in there not just because I like to watch you suffer. Now most of you, if you're going into nursing, are going to be required to have a bachelor's degree at some point. And every bachelor's degree program that I know of for nursing has a statistics course in it. And basically any medically related bachelor's degree that you would go into will have a statistics course in it. A lot of people fail to see the importance of statistics, but it's probably the single most powerful tool out there once you get into, well, medical fields. I used to do it in manufacturing, and statistics was huge there as far as quality control and stuff like that as well. So in practice, once you understand it, statistics is one of the more powerful tools you have in math. Okay, for the textbook, hopefully you guys all have this one. It's Math for Health Sciences. Joel Helms is your author. If anybody has anything different, let me know. Or if you don't have it, I know there were some bookstore issues with some of the text, but they didn't have enough ordered in. So if you don't have it, let me know and we'll hopefully get things figured out for you. A scientific calculator is not required, but very, very highly recommended. I get asked, the last few years, everyone wants to use their cell phone. That's fine if you want to use your cell phone as a calculator. Depending on your program, some of your programs that require or have math type problems, some of your programs will not allow you to use your cell phones on your tests. I know last I heard, they may have changed it this year, but I know the nursing program, you have to have dosage calculation exams every semester. I know you're not allowed to use your cell phone as a calculator on those, unless they changed it in the last little bit. If you have a calculator, it's most likely good enough. I recommend just a basic scientific calculator with fraction functions would be wonderful, like a TI-30 or a Casio FX. If you have a graphing calculator, that'll do wonderful. You can use that. The only thing the graphing calculator is a little weak on is fractions. It doesn't do them very well. But if you don't have a graphing calculator, you don't have to go out and spend your money on one right now. That's what I use up on my screen here, you can see, but that's because that was the one app I could get for free without having to pay for it. Okay, I already went over our competencies and units. So next is grading. Because this class is over the network, really isn't practical for me to grade homework. Besides, we're all adults here, so I'm trusting that you guys are doing the homework necessary to learn the material. I also kind of take the attitude on homework that it's a tool for you to learn. It's not a tool for me to grade. So if you're doing the first couple of problems and they seem really easy, I don't mind if you skip ahead a few to the more difficult ones. I'm not about you guys doing busy work on stuff you already know. So if you already know it, skip ahead and do the more difficult ones. Make sure you do enough that you're confident when you get to a test you can do it. Because one of the little quirks with math is it always looks really easy when we're doing it in class. I'll do it up on the board and it'll look easy. I might give you a question to try in your notes and it goes really well. But the thing there is, we just saw the process, so you know what process to use. In math, doing the process is the easy part. It's figuring out which process to do that's the tough part. So when you're sitting there staring at your homework, even though you did all the different types of problems in class and they were fairly easy, it can be a very much different story when you're sitting on your own doing the homework, trying to figure out, okay, which process goes with which problem. So make sure you're doing enough to figure that out. So in here, all of your grade is completely determined by the average score from the 5-unit test. Now, that's not as scary as it sounds. When you do your tests in here, after I grade them and hand them back, I do allow you to redo the problems you got wrong, turn them back in, and I give you back up to half your points for them. Now, with that said, don't just redo them quick and hand them back in. If you need to work with somebody else or if you need to ask me, I'll even walk you through doing the questions. I want you to do them all correctly. So you get back 2 reasons. One, so you get back as many points as possible. And also, I want to make sure you have the right answer down there so you can refer to it later if you ever need to go back and restudy it. So make sure that when you do those corrections, you're absolutely certain you've got them all right. We use the standard WITC grading scale in here, so I'm sure you've seen that a couple of times before. The rest of this is just our policies and procedures from the handbook, just stating that everything that's in the handbook still applies in here. They make me put this one in here for academic integrity. Don't cheat. Shouldn't have to say too much more about that. I don't mind if you work together on the homework, because homework isn't graded, so go nuts on that. Just make sure you're ready for the test. For accommodations, whether you have a documented disability or something else, maybe it's just you haven't had math for a while and you're really nervous, or maybe in a room where there's a lot of activity, you have a hard time concentrating to take a test. Whatever it is, just let me know and we'll see what we can figure out to help you out. I view it as, since this is not a core course, I view it as my job to do whatever I can to get you through this course to prepare you for what you need in your programs. And then my disclosure on the podcast, this is recorded, it's out there publicly. I won't use it against you in a court of law, but it is out there for other people to see. If you do want to disclose anything, really personal, go ahead. I do need to retire someday. I might need to supplement my income. So if you want to confess to any major crimes or whatever, I'm just kidding. Sort of. Okay, so our 5 major units are listed out again there for you. That's the order we'll go through them. Any questions on the syllabus, procedures, anything like that? Okay. So like I said, this class is pretty straightforward. Just the 5 tests that you have to make sure you're prepared for. Now, I know some of you have contacted me already about scheduling conflicts, and I understand that those come up. They happen to fall on a day where we're not taking a test. Just view the recordings and do what you need to for the homework. If it's going to fall on a day where we do have a test, I should go back to that assignment schedule here quick. Just get in touch with me and we'll figure out some other time you can take the test. The biggest thing is I just don't want to have you taking it too far afterwards. If there's a Friday that you have to be gone, I'd really prefer that you take it Wednesday or Thursday before if you possibly can. At the latest, Monday or Tuesday the week after. Because I like to sit down and I like to grade all my tests at once. It's just way more consistent. If I grade some of the tests on Friday afternoon, then I come back and grade another handful of tests the next Wednesday, I could be in a different mood. Something could have happened, and one problem that I would have given you partial credit for, I may have decided, well, that's not a mistake they really should have made or whatever, and not give you partial credit for it. So it's just better if I can grade them all at once. I like to keep them kind of tight, so if you miss a test, try not to wait all the way till the next week or anything like that to make it up. So anyway, on our assignment schedule, you can see here, I only have 15 weeks listed out. I've got exam 5 listed in week 15. This is, we do have 16 Fridays in here this year, if I've got the schedule right. Well, we might have got cut back to 15 now with the Thanksgiving deal. But when that 16th week comes in there, the reason this is like this is because this course for years was only offered in the spring, and we lose Good Friday in the spring. So we only got 15 classes. So when that 16th class comes up, I just use it as an extra week to make up topics. If something comes up, we lose a day or whatever. Otherwise, if we don't have any issues, I usually put that extra time in Unit 3, which is the dosage calculations, just because that's the most important topic for this course anyway. Okay, any questions? Well, as you saw in the topics, our first unit is basic, it's arithmetic and basic algebra. And I start out with some fairly basic concepts just because I found through the years that most of the problems that students have with the more advanced topics come from not completely understanding the basics. But the way I'm going to explain them hopefully is a little bit different than what you've seen in the past, because you've already seen these before, and seeing it the same way probably isn't going to do any good. But also, we tend to view math as a set of rules, and we never really understand where those rules come from. So one of my goals in here is to give you a little bit more of an insight as to why we do things the way we do, instead of just how we do things. So let's take a look at as an example, one of our most basic concepts in math, but also one of our most misunderstood. And that is, what is a number? Excuse me. If I put a 4 up here, just a show of hands, how many of you would tell me that that's a number? Yeah, most would, right? Technically, that is just a numeral. It is an amount. It's telling us how much. To truly be a number, it has to tell us how much, but it also must tell us of what. So I might say 4 cows. Now that's a complete number. We have the amount, how many, in this case 4, which I'm going to call the count. And then we're told what it is we have 4 of. In this case, the cows, I'm going to call that the name. Now I'm pointing this out for a couple of reasons. I'm normally not one that's a stickler on labels. Usually don't get too picky if you don't put the inches or whatever on there. For this class being medical math, I have to be, because your labels are very important. If it's supposed to be 5 milliliters compared to 5 microliters, that's a big deal. I mean, if you're dealing with morphine, 2 milliliters is a good painkiller, 2 microliters is a good painkiller, 2 milliliters could be heart failure. So, I mean, those units are very important. The other reason is, if you use both parts of the number and you work with both parts of the number, it explains how our operations work and what we can use in each operation. And all those special rules we learned for the different forms of a number come from these two parts. So let's look at our most basic math operations. We're going to look at addition and subtraction together. I'm lumping those two together because they are really the same operation. Addition and subtraction are the same operation, just addition goes in forward and subtraction is going in reverse. And then I'm going to lump multiplication and division together. So any rules that I talk about for multiplication also apply for division. So let's take a peek at an addition problem here. Let's take something like 4 inches plus 7 inches. What am I going to get for that? 11 inches. Good. Hopefully you knew that on your way in the door, so it's nothing new. But let's take a look at how the two different parts of the number fit together here. Let's look at our counts. We had 4 and 7, and they combined to make 11. We were adding, so we combined them with addition. So when we add numbers, we combine the counts. If we were subtracting, we'd combine them with subtraction. Let's look at our names. We had inches, and they became inches. They stayed inches. When we add, we keep the same name. Might not be terribly interesting so far, but it works differently when we get to multiplication and division. If I have 4 inches times 7 inches, what am I going to get? Well, 4 times 7 is 28. What? Not inches, but inches squared. When I'm multiplying, I have my counts 4 and 7. We still combine them. We're multiplying, so now we combine them with multiplication to get 28. So we still combine the counts. But the big difference came with our names. We had inches, and it became inches squared. So when we multiply numbers, we also combine the names. Now you might be looking at that thinking, well, big deal. But that difference actually defines a lot of, well, almost everything we do with our different forms of numbers. And it it actually defines what we can actually use in each operation. For example, let's say I take something like 3 cows plus 5 boys. Do I get 8 cowboys? No, it doesn't work that way, does it? If I switch it around, 5 boys plus 3 cows, do I get 8 boy cows? No. Anybody with a farm background in here? I see a couple hands, kind of, maybe. You can tell me that this is a whole bunch of bull, right? A long way to go for a joke. But there's a point behind it. I'm a math teacher, which means I'm required to have a really stupid sense of humor. You'll get used to it. But there is a point behind that joke. When I add numbers, I keep the same name, which implies that I had to start with the same name. Here I had inches and inches. I kept inches. I kept it as inches. Down here, I didn't have the same name. So if I tried to add them, which name would I keep? Well, I don't know. So I cannot add or subtract numbers that have different names. To put that a little more concretely, I might have, well, let's do 5 feet times 2 pounds, or plus 2 pounds. Can I add those? No, they have different names. So 5 feet plus 2 pounds is going to stay just 5 feet and 2 pounds. But multiplying 5 feet times 2 pounds, when I multiply, I don't have to have the same name because I'm just going to combine the names. So I'll combine the counts. 5 times 2 makes 10. But then I'm going to also combine the names. Feet times pounds is foot-pounds. That's a unit of torque if you're looking at mechanics, bending if you're looking at structures for construction. In the medical field, foot-pounds gets to like your pressures and torques on joints and stuff like that. So when I multiplied, I did not need the same name. Now with that in mind, let's look at our other forms of numbers. Let's look at everybody's favorite. Fractions. Yeah, I caught the licks. I realized that if I asked people on the way in the door what is the topic they hate most about math or struggle most with in math, probably 4 out of 5 would say fractions. The other 1 out of 5 would probably say the teacher. So let's review. What's the top number called? Starts with an N. Numerator, there we go. And the bottom one is denominator. Good. Little pause there, man. I should probably mention I am a horrible speller. There's a reason why I teach math and not communications. I also understand that I do have pretty bad handwriting sometimes. So if anything ever appears up on the board that you can't read, I promise you it was intended to be in English. I probably either butchered the spelling or my handwriting was just that bad. So please don't be afraid to yell out if you can't read something. I promise I won't be offended. So let's look at this, numerator and denominator. What is a numerator? Well, every 10 years, our government sends out people to do the census, where they numerate the population. What are they doing? They're counting. Denominator. Well, we have different denominations of money, different denominations of organizations. To denominate means to classify or to give a name. So the numerator and denominator of a fraction are just a count and a name. A lot of people look at that 3/7 and they see 2 separate numbers, and it's not. It is a single number with 2 parts. Just like having 3 cows or 3 inches, here we have 3 of something. What we have is sevenths. We'll define that more a little bit when we look at fractions in more detail. For now, let's take a peek at some operations with those. If I have 3/7 plus 2/7, way back in like 3rd grade when you first started doing operations with fractions, that 3rd grade teacher told you when you add fractions, you must have same denominator, common denominator. Not a special rule for fractions. When we add any numbers, we must have the same name. It just looks different with fractions. They also told us when we add fractions, you add the numerators and keep the common denominator, right? 3 plus 2 makes 5, and we keep the common denominator 7. Again, that's not a new rule for fractions. When we add any number, we combine the counts, and we keep the same name. Now we're going to look at ones like 1/3 plus 2/5 in a little bit. We can't add those the way they are because they have different names, but we're going to look at renaming those in a little bit. How about for multiplication? If I do 3/7 times 2/7, how are we taught to multiply? Yep, just go straight across, right? We do 3 times 2 is 6, and 7 times 7 is 49. Again, that's not a new process for fractions. When we multiply, we combine the counts, and then we also combine the names. If we have our 1/3 times 2/5, well, just like with whole numbers, we do not need the same name to multiply. We're just going to combine the counts. 1 times 2 is 2. 3 times 5 is 15. So all those special rules you learned for working with fractions are not special. They're the same rules we use for whole numbers or any other form of numbers. Let's look at decimals, 0.21. If I were to try to pronounce that formally, that would be called 21 hundredths. Good. So if I were to add decimals, if I take 0.21 plus 0.3. Is that going to work? No, what's wrong with it? Yeah, we've been told you have to line up the decimal points, right? Why? Okay. Yeah, this doesn't work out. You get something really weird, 0.24 or 2.4, whatever. Well, the main reason why is we said this was 21 hundredths. This is 3/10. They have different names. So I just put a 0 on here now, and now it's 30 hundredths. That 0 on there, the decimal points automatically line up. Lining up the decimal points when we add or subtract decimals is nothing more than making sure they have the same name. If this were a more basic class, I'd actually take the time to write out numbers in long form and show you how the place values fit into that. In fact, we may do 1 or 2 examples if we have time here in the first hour. So anyway, I go to add these. 21 and 31 make 51. Where's my decimal point go? I'll bring it straight down because this is 21 hundredths. This is 30 hundredths. When I add, I keep the same name, so this better be 51 hundredths. Bringing the decimal point straight down is nothing more than keeping the same name. If I want to multiply, do I have to line up my decimal point? Say no. No. Okay, good. So I'm going to 0.21 times 3. 21 times 3 is 63. Where's my decimal point have to go? I put in a 0 and then my decimal point, right? I have to have 3 decimal places in the answer. Can anybody tell me why? What were we taught to do? Not everybody at once. Plenty of time for everyone to participate. Okay. You're taught to count in the problem 1, 2, 3 total decimal places, right? Then you count back from the right. 1, 2, 3, and that's where your decimal point goes. But again, why is that the case? Well, when we multiply, we combine the counts. The 21 times 3 is 63. But we also combine the names. Hundredths times tenths make thousandths. When we're counting up those decimal places in the problem and putting that many decimal places in the answer, all we're doing is combining the names. Now that's probably all we're going to say about decimals in here. I'm just going to assume you guys can work with decimals. There'll be a little bit in the homework. I'm not going to spend any more class time dealing with calculations with decimals. We can also look at a basic algebraic number, 4x. A lot of people panic when we see that because the letters in with the numbers. But this is just like any other number. We can see we have the count, which is the 4, and the x is the name. So when we go to do anything with it, we might have 4x plus 11x. What are we going to get? 15x. Perfect. Just like any other number, we combine the counts when we add. 4 plus 11 is 15, and we keep the same name. So x and x make x. What if I have 5x plus 2y? What do I get? Yeah, I get 5x plus 2y, don't I? Can't do anything with it. Just like up here with my 5 feet and 2 pounds, I couldn't combine those with addition or subtraction because they have different names. Same with my algebraic numbers. For multiplication, however, if I have my 4x times 11x, I combine counts. 4 times 4 is 44. But I also combine the names. Just like inches times inches became inches squared, x times x is x squared. I get asked all the time, how come when we multiply it becomes x squared and when we add it stays x? Well, that's because that's how we work with all of our other forms of numbers. When we add or subtract, we keep the same name. When we multiply or divide, we combine the names. Well, how about our 5x and our 2y? If I'm multiplying 5x times 2y, 5 times 2 is 10. And then just like feet times pounds becomes foot pounds, x times y becomes xy. Yep. Good question. Do you have to put the dot? It all depends on how you write it. I mean, there's a lot of ways you could express that multiplication. You could have it like that with a parentheses around one of them. If you just did this, it's sometimes unclear as to whether that's, I mean, really, it still simplifies to 10xy. Oh, oh no. To me, that would be a waste. That'd be a waste of effort. Not to insult your high school teacher, but yeah. That's one of my pet peeves in math. I mean, here, I'll show you just a quick example. Like adding numbers. We were all taught if you're going to add like 468 plus 259. We were all taught that you got to start at the right and work your way back to the left. Right? 8 plus 9 is 17. Drop the 7, carry the 1. 1 combines with 6 to make 7, plus 5 is 12. Drop the 2, carry the 1. 1 combines with 4 to make 5, plus 2 is 7. We're taught that's how you do it, right? But there are several other methods for adding numbers. In fact, I could do 4 plus 2 is 6. 6 plus 5 is 11, so 1 drop the 1. 8 plus 9 is 17, so 7 drop the 1. 6 and 1 is 7, 1 and 1 is 2, and 7. You get the same answer. I could show you 4 or 5 different methods for adding whole numbers that'll work every time. I'm not going to because I don't want to confuse you. But the point is, in math, we're used to being told there's only one way to get the right answer. Well, there's several ways to get the right answer. Now, there is only one right answer, but there are a lot of different paths to get there. And that's always one of my biggest pet peeves in math, is I know a lot of teachers that are like that. I showed you this, and I'm not trying to criticize anybody, I swear. But this is the method I showed you in class. You have to use this method on the test. For me, like I said, I came from engineering before I came into teaching. My goal is that you learn it and you remember it and you retain it, and when you need to use it, you know how. So if there's a method that makes more sense to you than the way I teach, you're more likely to remember that and use it later. So I would like you to use that method so that you remember it and so that it works for you. To me, math is about making it work for you, not about repeating what the teacher wants, the way the teacher does it. I don't want you to all turn into a bunch of little me's. That would be kind of scary. I want you to have your own style of math that works for you and that you can understand. Okay, so with all that said, I've got a couple minutes here in the first hour. I want to show you just one little thing. I'm not going to talk about place values specifically and listing them out because I'm going to hope you guys understand where the place values come from. But I want to look at like 463. We're used to seeing numbers written like that, but that's just an abbreviation. The full number really looks like this: 4 hundreds and 6 tens and 3 ones. You know, we use that place value setup with the decimals and commas and all that to just imply that the 6's in this spot, so we know that's tens. When we write it out like this, however, it becomes obvious to you that this is not just a 6, it's 6 tens. Every digit of a number has a count and a name. So when we go to add, what was the big thing we were taught about adding? I had 463 plus 235. The biggest thing we were taught is adding or subtracting is you have to make sure you line up your columns of your numbers, right? Well, that's because when we add or subtract, we can only combine things that have the same name. I can only combine 3 ones with other ones, with 5 ones. And I can only combine my tens with other tens, and my hundreds with other hundreds. So that's why we have to be so careful about lining up the columns. When we multiplied, if we had something like 32 times 21, we didn't just go straight down the columns. You know, if it was decimals, we don't have to line up decimal points or anything like that. The reason is when we multiply, we don't need the same name, which means that this 1, 1 here, not only can it combine with the 2 ones, but it can also combine with the 3 tens, because we're not restricted to only combining things with the same name. So that's why when we multiply, we don't just go straight down the columns, we fan it out. So our long multiplication is nothing more than a process for making sure we multiply every digit in one number by every digit in the other number, because we can when we multiply. If I had more time, I'd go off on a tangent on long division on you. But one thing we're not going to get a lot of time to do in this class is integers, but I do want to take just a little look to help you deal with the negative numbers. If we're going to combine values like 5 plus 3, we're going to ignore the counts for now and just look at combining the counts or the amounts. To understand how that works, we need to understand how those values are actually represented. And in math, the number line is an extremely powerful tool that we tend to ignore as we move up in the levels. There are a couple of different ways we could represent the value 5 on the number line. One of them, and probably the simplest one, is just putting a dot at 5. If we wanted to represent a bunch of different values, that would be a fairly easy way to represent it. But if we want to do anything with it, that's not a terribly useful representation. A more useful working representation is what we call a vector. And a vector is just a really fancy word for a very simple concept. A vector for 5, as we saw there, it starts at 0 and it goes to 5. In fact, it could start anywhere and go 5 units to the positive direction. I mean, I could move this. Here, now it starts at 4 and it goes to 9. It's still the vector for 5. So I move it back here. So doing 5 plus 3, I have my 5. My 3 is going to look like that. Start at 0 and go to 3. The process of addition is just physically combining numbers. So I just put the two vectors together to get one long vector. 5 plus 3 makes 8. Now you guys hopefully all knew that without having to draw out vectors on the number line. But it helps us define something like 5 plus a negative 3. The vector for negative 3 is just going to go in the opposite direction. Goes from 0 to negative 3. If I combine that with the vector for 5, that will work real well. I go to move that over here. Come on, let go. There we go. We can see 5 plus negative 3, it ends up at 2. Now, when I work with negative numbers, I don't draw out number lines, but I do keep that picture of the vectors, the arrows in my mind. If I have something like a negative 17 plus 25, I'm doing this. Here's 0. Negative 17 goes in the 0 direction. 25 is positive, so it goes the opposite direction, and it's a little bit longer. So it takes me to the positive side of 0. That tells me my answer is positive, and since the vectors point in opposite directions, the values are subtracted. It's the difference between the values. So the difference between 17 and 25 is 8, so it's a positive 8. If I had a negative 11 plus a negative 32, well, here's 0, and negative 11 goes this way. Negative 32 goes the same direction. That's telling me my answer is negative because I end up on the negative side of 0, and the vectors point the same direction, so I'm adding or combining the values. 11 and 32 make 43. Does that make sense? Okay. It's the end of our first hour here, so I'm going to go ahead and we'll take our break. It's 11:20. We'll come back at 11:30, and we'll start our second hour.